All right, guys, your guided notes for the weekend are on a small theorem called the rational root theorem. And it's a real quick concept. We're not going to practice it too much. We're just going to have these notes on these 3 practice problems. And we'll utilize it. It'll be on the test. But it's just one quick rule that you can remember. So the checklist here says that you're going to be able to factor polynomials by using this new theorem, the rational root theorem, to determine which numbers are potential roots of the polynomial. So the reason we need this is, in the past, let's just take a look at letter A real quick. In the past, I might give you something like this, and I would say, find all the roots. But it's a cubic, so I would give you one of the roots, and then you'd have to find the other 2 using the quadratic formula, or completing the square, or double bubble, or whatever works for you once it becomes a quadratic. But this theorem is going to help you narrow down the possibilities of that first root so that I don't have to give it to you anymore. I can just say, here's a cubic or a 4th degree polynomial, 5th degree polynomial, find all the roots. And you can use this theorem to help you find those roots. Now, it's not easy, and it's not, let me rephrase that. It is easy, but it's not guaranteed that it's always going to work. And it's not necessarily quick if you do it by hand. So I'm going to show you how to do it using Desmos. And you can also do this on your graphing calculators as well. So we'll practice that a little bit once we get into class. First of all, before we do anything, I want to write down what the rational root theorem is. What it says is, so that's rational root theorem. If you have a polynomial of the form, so we've got x to some power, right? And then it's going to have a term after it that's 1 power less than that, and it's going to have a term after that that's a power less than that, all the way to when we don't have an x at all, right? But these all have coefficients. So there's a coefficient here, there's a coefficient here that's some number as well. And in the end, you just have some coefficient all by itself. So we've got this polynomial, and we set it equal to 0. If this is our polynomial, then our possible roots could be plus or minus all of the factors of the constant. That would be our a sub 0 right now, over all of the factors of the lead coefficient. Which in this case is a sub n. So I know that that looks like a lot right now. Let's apply it with a. So a is a cubic. So our a sub n here is a 1. Right, that's a 1. We don't have an x squared term, so that's a 0. But it doesn't really matter here when we're talking about the rational root theorem, right? We're looking at a cubic. We need to find one of our roots so that we can factor it out, and then we can just use a quadratic formula, and that'll be very easy. So let's use our rule. We're going to have plus or minus all the factors of our constant. Our constant is negative 12, right? So factors of 12, that could be 12. It could be 1. It could be 6. It could be 2. It could be 4. It could be 3. Right? Those are all possible numbers that are factors of 12. Divided by plus or minus all the factors of 1, which is our lead coefficient. And the only factors of 1 are 1 in itself. Okay, so what this is saying is that we could just be checking all the numbers in the world. We could test 37. We could test 82. And, you know, there might be numbers out there that are roots that we don't find by doing this. But what we're learning here is that we got a lot of possible roots. We've got 12 over 1. That's one possible root. We also could have negative 12 over 1. It's another possible root. And those 2 roots came from using the positive 12 and the positive 1. And then I used the negative 12 and the positive 1. Those are possible roots. We also have possible roots at negative 1 and at negative 6 and at positive 6 and at 3 and at negative 3, right? We got a lot of different options here, a lot of possibilities. But what we've done is narrowed the search to these possibilities, and one of them could be one of our roots. So we're going to test these. Now, if you test them all by hand, it's going to take a really, really long time. So don't test them all by hand. Use Desmos. So here's what makes Desmos so great. We can put our function that we have, this x cubed, and what is it, minus 13x minus 12, into here. And as long as we give it a name, like let's call it f of x. As long as we give it a name, now we can test each of these numbers really quickly. So if I think 12 is a possible root, because I just used the rational root theorem, and it looks like 12 is a possible root, then I'm going to try just punching in here f of 12. And it says that f of 12 equals 1,560. So it's definitely not a possible root. Let's try negative 12, because that's another one we could have. That's not it either. How about 6? Nope. How about negative 6? Nope. How about 2? Nope. Negative 2? Nope. Keep testing all of these numbers until you eventually find one of your roots. We used the rational root theorem to give us the possible numbers that we could plug in, and we found one. Negative 3 is a root because if I plug in negative 3, I'll get 0. And you don't want to do it by hand because that's going to take forever. So you'll use Desmos here. We'll use our graphing calculators in class. So now you know that negative 3 is a root. So if you know negative 3 is a root, you can use your polynomial. You can do some synthetic division. And you can factor that negative 3 right out of there. And now you have a quadratic. X squared minus 3x minus 4. And to find the other two roots, all you have to do is either the quadratic formula or completing the square, or in this case, double bubble. Because remember, double bubble is super fast as long as it works. And my numbers here are going to be negative 4 and positive 1. Those are the numbers that multiply to negative 4 and add to negative 3. So my roots are negative 3, negative 1, and 4. I used the rational root theorem to find the first root, and then once it was a quadratic, I had methods that worked no matter what, so I don't have to use the rational root theorem anymore. So I can just do the first one, and then I can use the quadratic formula on the rest, or the double bubble method, or completing the square. B, I'm going to do a separate video that goes on YouTube for B. B is also a cubic, so we'll have to use the rational root theorem to find the first root. Then we'll be able to use the quadratic formula or double bubble. But for C, C is not a cubic. So we'll have to use the rational root theorem twice. Then it will become a quadratic. Then we can use one of our methods that always works. All right? So all I ask is that by Monday you've got these notes completed. So I'm glad you watched this one. Make sure you watch the other one as well so that when you come to class, you've got just this front page of this sheet of paper filled out and ready to go. All right, guys, enjoy your weekend.